Hello folks, this is Jim with Science Talk. I want to discuss with you in this video what's happening to ocean productivity as the climate warms. Before I do so, I want to remind everyone that to please share my videos, to please subscribe to my channel here on YouTube, to hit the bell so you know when I drop the video in. I also ask you to support my work. Please go to patreon.com/Science Talk with Jim Massa. For as little as $3 a month, or more if you're so inclined, you will get the latest scientific research news as I discuss a variety of stories and topics, including not just climate, but evolution and other topics. I am also on Steemit. You can find my work there. Steemit, though, you do have to set up an account there that takes a day or two or three for them to approve and set you up. But please support my work. I feel that this information is important and needs to get out there to a great many people. Okay, so what do we got going on here? Climate change, and if it runs away, will alter the pattern of ocean productivity and circulation and play perhaps irreversible havoc, particularly with fish stocks. So, global ocean productivity. Typically, this is a yearly event of where phytoplankton bloom, and then we get all sorts of organisms. It's from zooplankton, invertebrates, fish, whales, seals, and so forth. Now, in some prior videos where I discuss water mixing, what is important is that you have some sort of a vertical overturn, a mixing vertically, so that nutrients can be brought into the photic zone. But then, following this mixing event, you need a stratification so that the phytoplanktons are kept in the photic zone and can do their thing. This is true whether it's a lake system, freshwater system, or the open ocean. I talked about the mixing regimes in the open ocean, concentrating on the salinity and temperature scenarios, but the same thing applies there. You need some sort of vertical mixing followed by a stratification. You warm up the upper layers of the water, you stratify it because the upper layers of the water are warmer, so they're less dense, and they sit there. The nutrients are locked in place, the phytoplanktons are kept in the photic zone, and off we go with the productivity. So, with the changes going on with climate change, the productivity of the ocean is at extreme risk. The harvest from the North Atlantic could fall by almost 2/3. The decline in the Western Pacific can drop by 50%, 50. The overall productivity of the oceans from pole to pole will be at least 20% less, 1/5. Global warming is already melting the ice caps. It is also making the seas more acidic. CO2 plus water makes carbonic acid. Decrease the pH, organisms that rely on shells or tests, they're called, will start finding that they're dissolving around them. That affects their survivability. This in turn can change how much fish is caught, what we call harvested fishing mortality, if you will. And of course, not to mention the bleaching to coral reef systems that we're already seeing. So in this latest study, it examines not just only the immediate consequences, but long-term. So scientists report in the journal Science that 3 centuries of continuous rise in CO2 levels in the planet's atmosphere could raise global average temperatures by 9.6 degrees Celsius. That's 10 times the warning that's already been observed. When you have that much of an increase in air temperature, that's going to change wind patterns. Be it Hadley-Sells trade winds, what have you. Jet stream, it's going to change wind patterns. And if you're changing wind patterns, you're going to start affecting ocean circulation. As I've said before, if you don't have the vertical mixing in the water column, you're not going to drive the conveyor belt. You shut down the conveyor belt, the Antarctic divergence zone, that the Southern Ocean productivity crashes. You might create, if you have such warmer waters on the surface, you're going to create situations where there's no vertical mixing, no nutrients can be brought up into the photic zone. That system will collapse. Increase in temperature comes changes in the growth of phytoplankton. Phytoplankton is the basis for all marine life. There will be shifts in ocean circulation that will take nutrients from the surface and deposit them in the deepest waters and not allow them to be remixed up into the upper layers of the water. And as I mentioned in a prior video about when I mentioned thermoclines, haloclines, and pycnoclines, warmer surface waters may very well lead to a permanent pycnocline in the upper oceanic waters. Now there is a permanent pycnocline found in the ocean, and that's typically down at about 1,000, 1,500 meters. And what have I mentioned? With the North Atlantic deep water, it typically flows back at 1,000 meters, basically right above that permanent pycnocline. So there's a permanent pycnocline there. We're talking about a pycnocline in surface waters. There could be a permanent one there that will prevent surface mixing. Phytoplanktons can't get their nutrients, they die, the whole ecosystem, the food chain, collapses. This is not hyperbole. This is a very realistic scenario that could happen. Now, these scientists state in their study that Antarctic waters could become richer in nutrients, but the world's human population is centered in the northern hemisphere. Marine ecosystems everywhere to the north will be increasingly starved for nutrients, leading to less primary productivity by phytoplankton, which of course is the basis for the ocean food chain. This is a statement by Keith Moore, who is an Earth System scientist at the University of California, Irvine. But I would disagree with him about his statement of Antarctic waters becoming richer in nutrients for the reasons I have already discussed. Shut down the AMOC. You don't have the deep water upwelling with the nutrients. That system collapses. So, time is actually running out for the oceans. Okay? Humans need to respond to this situation. We need to get off of fossil fuels and develop alternative energies. And even if we would do so today, even if we would stop all combusting of fossil fuel, there's enough inertia in the system that the effects of this can be still felt for decades, if not centuries, to follow. So I wanted to share this with you to give you an idea of some of the consequences of human activity, and to basically sound the alarm that we are in essence going to be killing ourselves, not to mention most life on this planet. There's indications, very strong indications, that we are in the midst of a sixth extinction, mass extinction event. Elizabeth Colbert wrote a book titled Sixth Extinction. It's an excellent work. I recommend her book highly. And not just only habitat degradation, but just and pollution, but the climate change, which of course is a form of pollution. So in the end, we're only really killing ourselves. As I discussed in my Rachel Carson video, when she basically stated that humans need to realize they are part of nature, not separate from nature, and that if we destroy our environment, we are basically waging war against ourselves and killing ourselves. She was correct in that assessment, and that is what's happening now. Thank you for watching. Please share this video. Please support my work.